Hi everyone. In this video, I'm going to show you how to build an artificial neural network classification model using TensorFlow and Keras framework that can predict whether a user will click on an online ad based on the given factors or parameters. So for the dataset, I am using M2 advertising datasets. It contains user and ad-related information used to predict whether a person clicked on an online ad. The target variable is click on ad, and the input feature includes spend on site, age, income, internet usage, location. So before we start doing a model, we need to import certain core library and utility. That's including NumPy, Panda, TensorFlow, and some utility for capturing the score, like F1 score, classification report, and confusion metrics. So to load the data, I'm using I created a variable called data underscore block, which is basically the location of my data file. Then I'll read it in using the panda.read underscore CSV. And I store that data file into a new variable called data underscore df, which is short for data frame. So I already run the cell already. So before you start modeling, it is best to understand the data sets. And there are a couple built-in Panda library or function that you could actually use to explore your data set. One of it is basically the shape, like understanding how big the data set is. And that is basically, you can use the dot shape function. Here, I ran the dot shape. As you can see, the data size is 1,000 by 10. So basically 1,000 row, 10 features. And then you can also display some basic information about the data set using the dot info. And here's the result. As you can see, there are 10 columns and the name of the column. And over here, you can see how big is the data set. There are 1,000 rows, and then the data type for each of those data. For example, time spent on site is basically a float 64. Also for age is basically integer 64. So next is you want to check to see if there are any missing data using the .isNo. The result pretty much give you like a summary if there are missing data in the data set. But here, there are no missing data sets, so it's just basically 0. Earlier I meant summary, but actually sum of all missing. So if there are, let's say, missing data set for age, and there are like 3 of them, you would see 3 here. So there are no missing data set at all. Next, what you want to see is the actual display of information in the data set. And the best way to do it is basically using the dot head method rather than printing out like line by line. You could do that too, but if you do the dot head, basically display all the information for you. The first 5 row, you could actually display 10 row you wanted to. So here is basically the output of the dot head. And as you can see, here's all the information. Now it's like you need to explore and understand the data. What would be your X variable, basically your feature that the feature that being feed into model, and then what are your Y variable, which is your prediction target value, your Y. That is that you are predicting, or the model should be predicting. So in this case, as you can see, just let's go through here real quick. A user time spent on site, and their age, the income, the daily usage, internet usage. I guess this is like a high level description of the type of I guess add the city, either person is male or female, country where they're from, timestamp, and let me see, and then the click on add. So here is your prediction. Here is your prediction variable. You want to predict if the user is going to see the ad, going to click on the ad or not. Also, looking through this data, thing that might not be useful is like this one right here, the title of the ad, right? This probably not very useful. So that could be dropped. City and country, that is probably very useful information to feed into the model. But these are string, so they are not numerical. So model cannot handle string. So we have to basically convert that into a numerical value. So let's go to the next step where we actually do the data cleaning and data processing. So here is basically what I'm doing is I'm removing those unnecessary features that that we don't want to feed into models. So basically, I use the dot drop features. So I drop the timestamp, I drop the add topic line, and then we have to do categorical encoding of city and country to a like a Boolean value of zero, like a false or true, or binary 0 and 1. So that way it becomes numerical. It's become something that the model could actually understand and process. So this is what this code is doing and using the get dummy method to encode city and country. Next, I create a my input variable, my X variable, and my output variable Y. So here's just basically what I'm doing is I'm assigning everything in the data sets except the click on at column as my X variable. So I drop that. And then my target variable should just be my click on at column. So I'm taking the value of it, all the value associated in that data set. And here you can see a printout of the X variable or features, and then my Y variable, what that is my prediction variable. As you can see, here's the shape. Now it's basically become 1,000 by 10,000 by 1,209. The reason why we had this substantial increase is just because we did a encoding of the city and country above right here. That's why we did the encoding. And let me display the data again after we encode it. You can see that all the city and country, it's create the code automatically create the column for you, and it's true or false if it's not associated to that row. And then the next step is basically splitting the data into training set and test set. So the reason why you want to split the data into training set and test set is basically you want to train a model, you want to train everything at one, because then the model would not learn or could be overlearned. So here I'm using the train underscore test underscore split function that we import above. And I just basically assign to X train, X test, Y train, Y test. And I feed in the X variable, Y variable, and I assign the test side to be 0.2, which is 20%. So you want to separate the data, 80% of the data for input, for test, for training, 80% for training, and 20% for testing. And then this cell, I'm basically, I need to scale the data. So I'm using the standard scaler. Neural net train more reliably when the input are scale, so that are scale. Features like income, age, time spent online have very different range. So scaling prevent any one feature from dominating the learning process. So here I fit the training the training data, and I also basically you know fit the test data as well. And then let me display the result after the scaling. As you can see, it become normalized. The data become normalized, and it's pretty much almost ready to fit into a model. So now let's start going to the core of building the neural network. In order for, I guess, one more preparation to the data set, that is converting the data set, X train, the Y train, X test, Y test into a TensorFlow tensor. So since Keras model natively process tensor better, you could definitely feed in like the NumPy array that we just imported above as is, but as you have a very huge, very large data set, converting it to TensorFlow tensor, it's going to be more reliable, going to be much faster. So this code here, that's all I'm doing here. I'm converting my X train to tensor, Y train, X test, Y test, and then I create this variable input underscore dimension, basically taking the shape of the X train. So basically, this is what I'm going to use later on to determine how many parameters. So basically, this is just basically the number of parameter to features to feed into the model. Okay, next is now building the model. So here I am building the model. I'm building a function or creating a function that taking in the input dimension, a number of hidden unit or layer. In this case, I default that to 128, 64. I'll explain that a little bit later on. And then the activate function in Neuron, you have activated function like determine, your prediction. The value or the outcome. In this case, I use a sigmoid, best for binary classification. You could try different function like a ReLU, tangent, but you could try that out. But this is just basically one of the best function for binary classification. And then dropout rate, which I set into 0.2. I'll explain that later on. And then the landing rate default to 0.001. So here is the core of the model building. So in this model, so basically we are using the Keras sequential model. So basically there are the input layer, which I specify what dimension should be. And then got hidden layer. The first hidden layer is going to be 128 neuron. And then the second hidden layer is going to be 64 neuron. And then the output layer just basically going to be 1, followed by the activating function, the sigmoid. Basically, that's going to give you your result, your prediction result. And then I compile the model using Atom Optimizer for updating the code. And then I'll pass in the learning rate here. I'm using for keeping track of the loss. I'm using the binary cross-entropy. It's best for binary classification. That's basically predicting if the user clicking on the ad or not, right? And then for performance metrics, capturing accuracy, precision, recall, and ARC, which is stand for area under the work. And then I'll compile the model, and then I display the model result. So as you can see here, this is basically the neural net architecture that we just built above. So the first layer have 128 neuron, second layer 64, and output layer just 1. Okay. All right. So after we build the model, I'll just run it here one more time. So after we build a model, there are so many hyperparameter and tuning that we have to do basically to train the best model. So here's only a few parameters that I use to tune this model. So that's including learning rate, and I will basically train it on different learning rate, 0.01, 0.001, right? And the batch size is how big the data. So as you read in the file, how big are the batch? Like basically look at it as like a number of row or data that you want to read in each time. So I'm going to read in 16, 32 of each learning iteration. Then epoch, the number of training epoch. And then here's pretty much it. So now I call them the model that we build on top. Here's the model, passing the input dimension, learning rate, hidden unit or hidden layer, the activating function. In this case, I'm using the value. Let me change that to sigmoid to be consistent on at the top. Okay. And then I'm using the early stop. So what early stopping is basically I want to stop the model if the performance is not improving. So that way it does not become overlearned. So that's what I'm basically using, early stopping. And then I store the history of all the training as I go through a different training cycle. So that way, you could actually see what's going on with the model. And then here's just basically the result. And then I'll store the result in this variable. So what I'm storing as through each learning cycle, I'm storing the learning rate, the batch size, epoch, evaluation accuracy, precision score, and all that, right? And then here is basically, at where I stop, right? Basically, if the score, the learning does not beat, it's not better than the best score, then you break out. So that's early stopping. And here you can see from the history, it's just going through the different learning cycle and storing all the result for you and display the result. Let me run it one more time. This might take a little bit long, maybe 30, 40 seconds. One thing I forgot to mention, I set up CUDA. So basically that's using a GPU instead of CPU. If you need help on that, just message me in the message. I'll provide you some code to how to set up CUDA. So, okay. All right. Next is just basically looking at the model or evaluate the model. So here I basically print out the loss, the accuracy, precision, the recall, the F1 score, the ROC, right? And then the confusion metrics. So I guess let me just go over some of the result. What do they mean? So after the training, I pretty much test the best model, basically right here. I store in the earlier function, we store the best model, basically the model that gave us the best performance. Then here I'm using that model to predict the score or the result, all this result right here, all this result. And then let's just go over some of the result. What did they mean, right? So accuracy tell me the overall percentage of accurate prediction. So in this case is 89% accuracy. That's pretty good. Precision, basically 94%. Precision show how reliable the positive click prediction are. So it's pretty, I guess it's pretty good. It's 94% accuracy, right? I guess a prediction. And then recall score, F1 score, the ROC. F1 score is like it's a balance between prediction and recall, which is useful when those two metrics are like just trade-off, right? And then the confusion metrics. So basically, it's it's the classification report to help you understand, how the model make prediction. There's it's like false positive, true positive, false negative, true negative. So basically, it's like how the model predict how how it does the prediction. So I hope you find this tutorial very useful. And leave me some comment if you want. Leave me some comment if you have any question about the code. I will provide the answer and respond to your comment. Thank you very much.